Carbon is the fourth most abundant element on Earth. All organic compounds contain carbon. Carbon is considered the backbone of biology because all life forms on Earth are carbon-based. Carbon has three main solid-state allotropes: graphite, diamond, and fullerenes. These allotropes differ greatly in structure but are widely used in modern production. Carbon has very high melting and boiling points. Graphite is the most thermodynamically stable allotrope of carbon under ordinary conditions. In diamond, the more stable allotrope at extreme pressures, each carbon atom is bonded to four others in a tetrahedral arrangement, resulting in the hardest naturally occurring substance known. The physical properties of carbon vary widely with the allotropic form. Diamond is highly transparent while graphite is opaque and black. Diamond is one of the hardest substances known to man, and graphite is soft and often used as the lead in lead pencils. Carbon is very brittle and cannot be rolled into wires or pounded into sheets. Carbon does not dissolve in or react with water or acids. Carbon also has the ability to make long strings or chains of atoms and forms more compounds than all other elements combined. Carbon is most commonly obtained from coal deposits, although it usually must be processed into a form suitable for commercial use. Natural diamonds occur in the rock kimberlite, found in ancient volcanic necks. Diamonds are now also being recovered from the ocean floor. Graphite is naturally found in vast quantities in places such as the United States, Russia, Mexico, Greenland, and India. Graphite is also used in pencils, to make brushes and electric motors, and in furnace lining. Activated charcoal is used for purification and filtration. It is found in respirators and kitchen extractor hoods. High concentrations of CO2 in the air can cause headaches, dizziness, confusion, and loss of consciousness. Atmospheric carbon dioxide allows visible light in, but prevents some infrared escaping. This is the natural greenhouse effect. This keeps the Earth warm enough to sustain life. However, an enhanced greenhouse effect is underway due to human-induced rise in atmospheric carbon dioxide. This is affecting living things as our climate changes.
And I'm Gonzalez, representative of Tonito Gonzalez, Vice President of Shell. Former Vice President of Shell, indeed. Well, gasoline is derived from fossil fuel, which comes from the buried carbon-rich remnants of ancient animals and plants. The key physical properties of gasoline are that it is clear, liquid, highly flammable, and has a nauseating smell. Gasoline is highly combustible when mixed with air. The combustion of gasoline creates energy and forms carbon dioxide and water. Well, gasoline comes from crude oil, which looks like a liquid form of asphalt. Gasoline is refined from crude oil. Crude oil is derived from fossil fuel, which comes from buried remnants of ancient animals and plants. Fossil fuels can now be found all around the world. The cumulative effects of using oil as fuel affects the environment negatively. Cleaner alternatives are being used, but these are not enough to supply the energy needs of the world. Gasoline, diesel, LPG, kerosene, aviation fuel are all derived from crude oil. Carbon is a part of the composition of fossil fuels. Well, yes, you can plan to use less gasoline, be more environmentally cautious or conscious, travel using bikes or environmentally designed vehicles, or use public transport. The flammability of gasoline is necessary for it to be used as fuel for vehicle engines. The safety rules are good enough as long as these are followed. Carbon, as a part of hydrocarbons, can create many products such as other fuels, asphalt, and wax.
I'm Jordan Madrid. I'm a science research specialist in the Chemistry Research Laboratory of Philippine Nuclear Research Institute. So, in my work, I used to add functionalities to this polymer-based materials. For example, you can imagine a soft drink PET bottle. So you can add functionalities, functional groups. You can make it, you can turn it into something that can remove heavy metals from wastewater. So you can functionalize the insides, the inside part of this PET bottle. You can add functional groups using radiation technology, and then you can use it for treatment of wastewater. So it is possible because we have carbon-based material. Right now, they are not doing drafting, or they're not applying the technology which I'm using to non-carbon-based materials. So I can perform my research because I am dealing with polymers which are made of carbon atoms. These polymers are made of carbon-oxygen or carbon-hydrogen bonds. The carbon-hydrogen bond can be cleaved by radiation. But if I have a silicon-hydrogen or a silicon-oxygen bond, then it will be difficult to cleave this using radiation. So I can perform modifications by removing the hydrogen atom attached to the carbon atom easily using radiation. On the right side, this is the polymer, the non-woven fabric modified using radiation technology. So as the material is immersed in the solution containing copper ions, then it is stirred. You can see it removes the copper ions from the solution. This happens because we put functional groups, chemical groups. We put chemical groups on the surface of the polymer using radiation technology, and these chemical groups are able to pick the copper ions from the solution. So it has lots of applications. Like in this case, it shows the take of copper ions, but you can also apply it to other metals like lead, mercury, cadmium, or other hazardous metals. Even proteins or other biological natural products can be removed using modified materials.
Silicon is the second most abundant element, with oxygen being the first. Pure silicon is a hard, dark gray solid, and it's also lustrous. Silicon has two allotropic forms, a brown amorphous form and a dark crystalline form. It's also soluble in hydrofluoric acid and alkalis. It's also conductive. It is flammable when the dark brown crystals are ignited. It dissolves only in a mixture of nitric acid and hydrofluoric acid. It does not occur uncombined in nature, but occurs chiefly as the oxide silica and as silicates. Silicon is one of the most useful elements to mankind. Most is used to make alloys. Silicon is also used extensively as a semiconductor in solid-state devices in the computer and microelectronics industries. Silicon may cause chronic respiratory effects.
Germanium is primarily obtained from the smelting of zinc ores and from the byproducts of burning certain types of coal. The largest use of germanium is in the semiconductor industry. Germanium is also used to create alloys and as a phosphor in fluorescent lamps. Some germanium compounds seem to be effective in killing some types of bacteria and are currently being studied for use in chemotherapy. Germanium has been reported to cause kidney damage, liver changes, and heart problems. Many of these effects improve after the supplement is stopped, but kidney and nerve damage persisted and became chronic for some people.
Tin is a highly workable metal that was once as valuable as silver for jewelry, coins, and special dishware. The most common allotrope of tin is a silver-white metallic-looking solid known as the beta form. A second form of tin is alpha tin, also known as gray tin, which is a gray amorphous powder formed when white tin is cooled to temperatures less than 13 degrees Celsius. It does not rust, corrode, or react in any other way. This explains one of its major uses, as a coating to protect other metals. At high temperatures, however, the metal reacts with both water, as steam, and oxygen to form tin oxide. Exposure to tin has been shown to affect the blood system.
Tin is a bright silver metal. It is malleable and it's a very good conductor of heat and electricity. Tin is a metal that is non-reactive with water, but it oxidizes when it comes into contact with an acidic or basic solution. We get raw tin is mostly mined from Indonesia, Peru, China, and Myanmar. You can get them from the recycling areas, from the recycling factories. So after the mining, if you can just visualize, it's mixed with the rocks. So first they have to physically separate the rocks, the sediments from the metal. And then it goes into the smelting, it's smelted to the smelting, to the smelters. So they separate the metal from the other sediments, from further impurities. They get a magnetic, it goes through a magnetic process. So after they get all the metals out from the sediments, they have to separate the different kinds of metals because there's tin and iron. So to separate that, they go through a heat process. Tin melts at a certain temperature and iron melts at a certain temperature, so they're able to separate the different kinds of metals. People buy tin because its unique characteristics make it a good conductor, because it doesn't react to water, and so it can be used for electricity. So again, in the microelectronics company, a lot of tin is used in the chips because that is the tin is soldered, it's placed or jointed into the chips so that those are the electricity can be channeled through the tin. And then in a smaller way, it also can be used for jewelry or some other ornaments. Right now, first of all, tin does not pose any danger to the health or environment. And in terms of price, functionality, and the tolerant environment, right now there's no better alternative. Maybe it's price.
Lead is the heaviest member of the carbon family. Lead is a heavy, soft, gray solid. It is both ductile and malleable. Lead is easily worked, meaning it can easily change in shape. It does not conduct an electric current, sound, or vibrations very well. Lead is a moderately active metal. It does not react with oxygen in the air readily and does not burn. Lead rarely occurs as a pure element in the earth, so it is usually harvested from its ores. Lead can also be extracted from old car batteries in recycling centers. Throughout history, lead has been used to make water and sewer pipes and as an additive in gasoline. But now products once made with lead no longer use it to reduce the amount of lead that leaks into the environment. This is because lead causes both immediate and long-term health problems, especially with children.
The lead was added to gasoline to improve the octane rating of gasoline, which then helped increase the fuel economy and performance of vehicles. Lead, though, is a toxic pollutant to the environment when burnt with gasoline. Lead also caused spark plug fouling of car engines.
The carbon family or group 14 family contains the elements carbon, silicon, germanium, tin, and lead, and they exist free in nature in the compounds. All elements in the carbon group contain 4 valence electrons in their valence shells, and because of this, they tend to be fairly unreactive. Their physical and chemical properties vary greatly because the carbon family consists of 1 nonmetal, which is carbon, 2 metalloids, which are silicon and germanium, and 2 metals, tin and lead.